A full-color Smith chart consists of two graphs overlaid on one another, a blue graph, which plots normalized admittance values, and a red graph, which plots normalized impedance values. To introduce the chart, let's start by looking at just the impedance graph. This is the impedance Smith chart. If you like, you can pause the video for a moment and print yourself a copy from the notes that accompany this lesson. The Smith chart is a mapping of the positive x half of the complex plane. In other words, any complex number with a positive real part can be plotted on the Smith chart. These are the lines of constant real impedance, or resistance, and these are the lines of constant imaginary impedance, or reactance. Positive reactances are graphed above the center line, and negative reactances are graphed below the center line. So if you wanted to read off the impedance indicated by this point on the chart, you would read the real part from here, 0.6, and you would read the imaginary part off here, 0.4. So the normalized impedance at this point is 0.6 plus j 0.4. Or, if we wanted to read off the impedance indicated by this point, we would read off the real part as 1.6, and the imaginary part as negative 0.8. So the normalized impedance at this point is 1.6 minus j 0.8. Values plotted on the Smith chart are always normalized to the system characteristic impedance. In other words, if I have a 50 ohm system and I want to plot a load impedance of 25 ohms, the 25 ohms must first be normalized by dividing by 50, and it will show up on the Smith chart as an impedance of 1/2. So for the two examples we just looked at, if the system impedance is 50 ohms, and we read the normalized load impedance off the chart as 0.6 plus j 0.4, we know that the unnormalized load impedance is 30 plus j 20 ohms. Or, if the system impedance is 50 ohms, and we read off a normalized load impedance of 1.6 minus j 0.8, the unnormalized load impedance is 80 minus j 40 ohms. Now, there are 3 points on the Smith chart that I want you to be able to identify in your sleep. The first is the center of the Smith chart. The impedance value at the center of the Smith chart is 1 plus j 0. This is the location of an impedance that is exactly equal to the system impedance. If you think about what we just covered in terms of matching networks, this means that the center of the chart corresponds to a perfect match. A load impedance located at the center of the Smith chart is perfectly matched to the system and will experience zero reflection. The further a load is from the center, the more reflection it will experience. The second point I want you to know is here, the furthest right point on the Smith chart. This is where the real part of the impedance becomes infinite. In other words, this is the location of an open circuit. And finally, all the way on the left side of the Smith chart, the real part of the impedance goes to 0. So this is the location of a short circuit. So the 3 significant points I want you to remember are match at the center, open on the right, and short on the left.